Hello and welcome to Math Age. I promised to make a video tutorial on this question. Write the name of a triangle with the vertices 1, -3, 6, 2, and 0, 4. The options are given. The first secret here is that this question is not testing just your knowledge of triangle names. It is actually testing whether you know how to compare the side lengths without actually finding the actual lengths. The hidden principle is when comparing lengths, compare the squares of the length instead of calculating the square roots. In this question, an ordinary mathematics student will start drawing the triangle, indicating the vertices as points A, B, and C, and showing their respective coordinates. While this practice is not out of place, but a competition student knows that he doesn't have the whole time to go through this. As a matter of fact, he's targeting to solve the question in less than 30 seconds. So going all through this will end up not finishing the question in 7 minutes. So what does he do? The first question that comes to his mind is, what are the principles being tested? Now, the first principle tested here is the distance formula. Do you know that the distance d is equal to the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared? But in competition, you don't find the square root unless it becomes absolutely necessary. You don't have the whole time. Another principle being tested here is classification of triangles by their side lengths. 3 equal sides is an equilateral triangle, 2 equal sides is an isosceles triangle, but when all the sides are different, we talk about scalene triangle. Let's call the points, the vertices of the triangle, as points A, B, and C with their corresponding coordinates. Instead of finding the length of the sides AB, BC, and AC, we find AB squared, BC squared, and AC squared using the distance formula without actually finding the square root because of time. We are going to take this in simple steps. Step 1, we consider side AB with point A at coordinate 1, -3, while point B as coordinate 6, 2. Now, the difference in the x coordinates is 6 minus 1, which is 5, while the difference in y coordinates is 2 minus -3, which is 5. So, AB squared will be equal to the difference in x coordinates squared plus the difference in y coordinates squared, which is 5 squared plus 5 squared, giving us 50. In step 2, we consider the side BC with the difference in x as 0 minus 6, which is -6, while the difference in y is 4 minus 2, which is 2. So, BC squared will be equal to -6 squared plus 2 squared, which is 36 plus 4, giving us 40. Please note that -6 squared is 36, not -36. Step 3, we do the same for side AC. Where the difference in the x coordinate is 0 minus 1, which is -1, and the difference in y coordinates is 4 minus -3, which is 7. So, AC squared is -1 squared plus 7 squared, which is 1 plus 49, giving us 50. Now we compare the three values, which represents AB squared, BC squared, and AC squared. So we discover that 2 are equal. Therefore, AB is equal to BC. Hence, the triangle is an isosceles triangle, and the answer is B. Let me talk a little about the hidden mathematics. Many students will waste their time calculating the square root of 50, the square root of 40, and the square root of 40 and 50. Please, there is no need for this. If AB squared is AC squared, then automatically AB will be equal to AC. This is one of the biggest competition shortcuts. The competition mindset is that when coordinate geometry asks about the type of triangle, immediately think of 1, compute the square distances only, compare the results, avoid square roots. Then you can decide the triangle type in seconds. I hope somebody benefited from this. Thank you so much for being part of this success journey. See you in the classroom. God bless you.